بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 3.3 derivative of trigonometric functions. Here we need to find the derivative. So g prime of x would be derivative of 3x is 3, and here I have product between two functions. So I will use the product formula. Product formula says f times g, derivative of f times g is f prime times g plus g prime times f. So derivative of x squared is 2x, and I write cosine x as it is, then plus x squared as it is times the derivative of cosine, which is negative sign. So I'll let this minus because the derivative of cosine is negative sine x. Please uh, look to the formulas in section 3.3 before solving these exercises to know and memorize the derivatives of trigonometric functions. Again, here I have product between two functions. So y prime would be the derivative of secant theta. Derivative of secant theta is secant theta times tan theta plus secant theta as it is, and the derivative of tan theta. Derivative of tan theta is secant square theta. So if you like, if you want, I can take secant theta here as a common factor, and this is tan times tan, which is tan square theta, and I have secant square theta here, and we have seen that tan square plus secant square is -1 because tan square theta plus 1 is secant square theta. Please also, in the previous video, there are a lot of identities between the trigonometric functions. You need to know them before finding the derivatives and simplifying trigonometric functions. So tan square minus secant square is -1. So the answer would be negative secant theta. Well, here f prime would be, again, I have a product between two functions, this parenthesis multiplied by sine theta. So I'll use the product formula. Derivative of parenthesis, derivative of theta is 1, derivative of cosine theta is negative sine theta, so this would be positive, times sine theta plus theta minus cosine theta times the derivative of sine theta, which is cosine theta. Okay, I will leave it like this. You can expand if you like. Let me, I don't think there is anything to find, because here this is sine square and this is negative cosine square. If it is sine square plus cosine square, then it would be 1. Here g prime of theta, I have product also. So the derivative of e to the power theta is e to the power theta times tan theta minus theta, as it is the product rule, plus e theta times the derivative of tan theta minus theta. Derivative of tan theta is secant square theta, and derivative of theta is 1. So that's the answer. Well, to find the derivative of cosine square t, we will learn a method in the coming sections, but now I can't. The only method I know is to write cosine square as cosine t times cosine t and use the product formula. So h prime of t would be derivative of cosine is negative sine t times cosine t, then plus, should be plus, let me write it plus, derivative of cosine t as it is, the first cosine, and then the derivative of the second cosine, which is, sorry, yeah, okay, the first cosine as it is, and the derivative of the second cosine is negative sine t. So this negative, which I'm going to write here, will make this negative, okay? So I have -2 sine t cosine t. This is the derivative of cosine squared t. Here I need to use the quotient formula. So what the quotient formula says, f derivative of f over g is g squared f prime times g minus f times g prime, or g prime times f. So I have 2 minus tan x all square. This is g squared. Derivative of x is 1 times minus tan x minus x times the derivative of 2 is 0. Derivative of negative tan is negative. Derivative of tan is secant square x. So I'll have minus 2 tan x plus x secant square x over 2 minus tan x all square. That's the derivative. Again, I have a quotient here. So f prime of t would be e t to the power 2 or e to the power 2t. Derivative of cotan is negative cosecant square t times e t and minus cotan t times the derivative of et, which is e to the power t. And now I have e to the power t as a common factor from the numerator, and then negative cosecant square t minus cotan t over e to the power 2t. So I can cancel this with one of these two, and the final answer would be negative cosecant square t minus cotan t over e to the power t. Again, here the quotient rule would be used. 1 minus secant w all square would be in the denominator. Derivative of 1 is 0. Derivative of secant w is secant tan. So this is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. And the derivative of the denominator is derivative of 1 is 0, derivative of negative secant is negative secant tan. So let us try to simplify. We will have here secant w. Well, I can take secant w tan w as a common factor. Always take a common factor. Okay, here I have two terms. Secant tan is there, and here negative secant tan, so I can take secant tan as a common factor. So I will have 1 minus secant w from the first term, and this minus will come with this minus, and it would be multiplied, it would be product plus. So I have plus 1 plus, there is no need for parentheses, plus 1 plus secant w. So if you take a common factor, it would be immediately like this. And now negative secant cancels with secant, and 1 plus 1 is 2. So the final answer would be 2 secant w tan w over 1 plus secant w to the power 2. Also here I need to use the quotient rule. So y prime would be 1 plus t all to the power 2. Derivative of the numerator. Well, the numerator is product of two functions. So the derivative of the numerator would be derivative of t, which is 1 times sine t plus t times the derivative of sine t, which is cosine t. This is the derivative of the numerator. You multiply by the denominator minus. You write the numerator as it is, and you multiply by the derivative of the denominator, which is 1. Okay, so I'm not going to write it. Or let me write it for your review. Okay. Do we have a common factor? I don't see a common factor. T sine t, it's not here. Okay, so let me multiply. So I have sine t plus t sine t plus t cosine t plus t square cosine t minus t sine t, and these two can cancel. And what do we have? Sine t plus t cosine t plus t square. So there is no common factor between them. So that would be the final answer. Sine t plus t cosine t plus t square cosine t over 1 plus t to the power 2. The next question, I have product of 1, 2, 3 functions. To find the product of 3 functions, I extend the formula of the product of two functions. So first, what is the derivative of t? It is 1 times et times cosine t without a change, plus now t as it is. And the derivative of the second function, which is e to the power t, is the same, times cosine t plus t as without change. And the derivative of cosine t, which is negative sine t. So the final answer would be e t cosine t plus t e t cosine t minus t e t sine t. And there is no need to take a common factor here because there are no uh, simplifications. This is the simplest answer. Now find an equation of the tangent line to the curve at the given point. You remember the equation of the tangent line is y minus f of a, or y of a, because this is y, okay, equals f prime of a times x minus a, where f of x here is y. So f of a is 1, a is 0, and I need just to find f prime of a. To find f prime of a, I'll find y prime. So the derivative of this function. Here I have product of two functions. So derivative of ex as it is times cosine x plus ex times the derivative of cosine, which is negative sine x, plus the derivative of sine, which is cosine x. Now, I'm not going to simplify this because all what I need is y prime of a, y prime at 0. And cosine 0 is 1, and e to the power 0 is 1. So the first term will give me 1. Sine 0 is 0. So the second term will be disappeared. Cosine 0 is 1. So in fact, y prime 0 is 2. So the slope is 2. So the equation would be y minus 1 equals 2 times x minus 0, or y equals 2x plus 1. That is the equation of the tangent line. Another question. So y minus 1 would be plus 1 equals f prime of pi, or y prime at pi of x minus pi. So I need to find y prime, and I have to use the quotient rule. So here I have cosine square x. The derivative of 1 is 0. The derivative of sine is cosine. So this is the derivative of the numerator times the denominator. So I'll have cosine square x minus the derivative of the denominator. Derivative of cosine is negative sine. So this would be plus sine x times 1 plus sine x, which is the numerator. Okay, I will simplify this first because I have cosine square x. Sine times 1 is just sine x, and sine times sine is sine square x, and cosine square plus sine square is 1. everything is x. Okay, no theta here. So cosine square x, cosine square x. So sine square plus cosine square is 1. So I have 1 plus sine x in the numerator and cosine square x in the denominator. I think this is beautiful. The derivative of y is y prime like this. So y prime at pi, this is what I need, 1 plus. Well, sine pi is 0. Cosine pi is negative 1, but it is cosine square, so it would be negative 1 to the power 2, which is 1. So 1 over 1 is 1. So the equation would be y plus 1 equals 1 times x minus pi. So that is the equation of the tangent line. Find f double prime. Well, let us find f prime first. So f prime, derivative of secant is secant tan. Now f double prime, I have a product function, secant times tan. So the derivative of secant is secant tan times tan, so it would be tan square plus secant as it is, and derivative of tan is secant square, so this would be secant cube tan. And now I can find f double prime of pi over 4. You can simplify this first. We did it, I think, in the beginning of this recording. So I need pi over 4, so I immediately find pi over 4. Well, what is secant pi over 4? You can find cosine pi over 4 in the calculator and then find the reciprocal of this of the answer, and it would be square root of 2. So secant pi over 4 is just square root of 2, while tan pi over 4 is 1 squared, and secant pi over 4 is square root of 2 to the power 3. So I will have square root of 2 plus square root of 2. When you raise it to the power 3, you have 2 square roots of 2, and then the answer would be 3 square roots of 2. I have f of pi over 3, f prime of pi over 3. Let gx equals f of x times sine x, hx equals cosine x over f of x. What do we need? G prime pi over 3. To find g prime pi over 3, I need to find g prime. Well, g prime of x is its a product, f times sine. So the derivative of f is f prime times sine x, and then plus f of x times the derivative of sine, which is cosine x. So g prime of pi over 3 would be f prime of pi over 3 times sine pi over 3 plus f of pi over 3 times cosine pi over 3. And either you use the triangles or the calculator to find sine pi over 3, or you know them, it's okay. Sine pi over 3 is square root of 3 over 2, and f prime pi over 3 is negative 2. Cosine pi over 3 is just half, okay, times f of pi over 3, which is 4, so plus 4 times half. So it would be negative square root of 3 plus 4 over 2 is 2, so that's the answer. H prime pi over 3. Well, H is given here, okay, and to find H prime, I need to use the quotient rule. So it would be f of x to the power 2, because f is in the denominator, and the derivative of cosine is negative sine x times f of x minus cosine x times the derivative of f, which is f prime of x. So h prime of pi over 3 would be equal to negative sine pi over 3 f of pi over 3 minus cosine pi over 3 f prime of pi over 3 over f of pi over 3 to the power 2. Well, sine pi over 3 is square root of 3 over 2. F of pi over 3 is 4. Cosine pi over 3 is half. F prime of pi over 3 is negative 2. F of pi over 3 is 4. And you simplify. So this would be negative 2 square root of 3. And this would be plus 1. And this is 16. So that's the answer. Find this limit. Well, we have seen that limit sine theta over theta when theta goes to 0 is 1. So what I can do here is I can take 1 over 3 out, and then I will have sine 5x over x. I need 5, so I will multiply by 5. So I will have 5 over 3 limit sine 5x over 5x, and when x goes to 0, 5x goes to 0, so it is 5 over 3 times this limit, which is 1, where theta is 5x, and the answer is 5 over 3. Well, here I will divide the numerator and the denominator by x. And now I have the limit of the numerator over the limit of the denominator. But in the denominator, I have sine pi x over x, so I need pi here. So I will multiply by pi here, and there will be pi here. And when x goes to 0, pi x goes to 0. So using the limit of this limit is 1, and this limit is 1 times pi. So the limit is 1 over pi. That's it. I hope you enjoyed this section. Thank you very much.